previous class number 026, we have seen that there is some limitations of the Bohr atomic models, and then it was necessary to improve the model of the atoms. And due to this shortcoming of the Bohr models, then attempts are made to develop a more suitable and general models for atoms. So there are two important developments which contributes the formulation of such a model, and these are: number one, dual behavior of matters, and number two, the Heisenberg uncertainty principle. Now we'll discuss one by one that dual behavior of matters and Heisenberg uncertainty principles. First, we'll discuss about the dual behavior of matter. What is this? The French physicist de Broglie, very famous physicist, in the year 1924 proposed that the matter, any matter, as for example like radiation, it should also exhibit dual behavior. That means this radiation should have that both particle and wave-like properties. This means that just as the photon, that means photon is an example, it has the momentum as well as wavelength. Momentum will show the properties of the particle. You have to remember this. And wavelength, which is denoted by the lambda, it will show the wave nature. So now we can tell that photon has the dual behavior of matters. And electrons should also have momentums and wavelength. So de Broglie, from this analogy, that means dual behavior matter, he gave a relation between the wavelength, which corresponds to the wave-like properties, and the momentum, which shows the particle-like properties. What is the equation? Equation is lambda is equal to h by mv. Again, it is equal to h by p. So this lambda, we know that this is the wavelength, and this m is the mass of the particle, and this v is its velocity, and this p is its momentum. So this momentum p and lambda, it has the relation by this equation. We have to remember this. De Broglie's prediction was confirmed experimentally when it was found that an electron beam undergoes diffraction. That means electron has the particle nature, and when it undergoes the diffraction, that means it is the phenomenon of the wave natures. So this is the experimental findings as per the prediction of the de Broglie's wave particle dual nature. This fact has been put to use in making electron microscope, because electron microscope use both the particle as well as wave properties of a matter or object. Now I'll talk brief about the electron microscope. Electron microscope is a powerful tool in modern scientific research because it achieves a magnification of about 15 million times. That means if an object you want to see under the electron microscope, then its size will increase 15 million times. And it needs to be noted that according to the de Broglie, that every object in motion has a wave character. And it is called the dual behavior of particles. So if we see this equation, then you see that wavelength will be very short for large mass. That means the wavelength and mass, it is the inversely proportional. So if it is more, then the wavelength will be very less. And if this is more, then this m, this mass, should be very less. So the wavelength associated with electrons and other subatomic particles which has the very small mass can however be detected experimentally because its wavelength will be large. Now I'll discuss about the Heisenberg's uncertainty principles. Werner Heisenberg, who is also the German physicist, in the year 1927, he introduced these Heisenberg principles. What is this? The Heisenberg uncertainty principle states that it is impossible, we have to remember this word, impossible, to determine simultaneously the exact position and exact momentum or its velocity of an electron. That means, as per the Heisenberg uncertainty principle, it is not possible to determine at one time the exact position and exact momentum of an electron or subatomic particles. So mathematically, he has given one equation. This is that famous equation, delta x multiplied delta px greater than equal to h by 4 pi. Or we can derive, because px we know the mbx, so we can rewrite the equation as per this: delta x multiplied by delta mbx greater than equal to h by 4 pi. Then ultimately the final equation will be, if m you take in the right side, then it will come delta x multiplied delta vx greater than equal to h by 4 pi m. So in this equation, that means this is the final part. This part, if you look into it, then you can see that when the delta x is the uncertainty in position, then the delta px, this portion, okay, this is this portion, or you can tell the delta vx, is the uncertainty in the momentum or velocity of the particle. That means if the position of an electron is known to be high degree of accuracy, that means delta x, in that case, high degree of accuracy, delta x will be very small. That means this portion will be very small. Then the delta Vx, it should be very high, because multiplication of these two parts will be greater than equal to h by 4 pi m. So make it right side constant, because m is constant, h also Planck constant, pi is constant. So right side is the constant. So if right side is constant, then left side, it is the multiplication of the two factors. So if delta x is very less or very small, then delta Vx will be very high. Delta Vx very high, what is means? That means for this delta Vx, that is momentum, has more uncertain in nature. So this one is written there, delta x is small, then delta Vx is large, and vice versa. That means when the delta Vx is very small, that means when the momentum or velocity it has the high degree of accuracy, then the position, that means delta x denoted by delta x, it will be very large. That means it has more uncertain in nature. And thus, if we carry out some physical measurements of on the electron position or velocity, the outcome will always depict a fuzzy or blurred picture. That means picture is not clear. Because in physical measurement, you always want to measure precisely both the position as well as momentum, but it is not possible as per the Heisenberg's uncertainty principle. And I hope that you clearly understood the dual nature, that means particle and wave properties of a particle or object, and uncertainty principles and their mathematical expression and explanation.